There. What I want to talk about is design thinking. It's an idea or two words that kind of describe an idea that's that's pervasive or has been pervasive in the States, especially in certain places, in business schools, in engineering programs, even in the US military, but oddly enough, not in design schools. The only place where they don't teach design thinking is in design schools, which I find kind of strange. So I want to talk a little bit about that and about what design thinking is. This is Roger Martin. He runs the Rotman School of Design Management in Toronto, probably one of the more progressive and interesting schools of management in the world. They are hiring designers who teach in their business curriculum. So if you do an MBA, you do a lot of design work there. Richard Florida is teaching there now. They're hiring a lot of interesting designers. This is another place where design thinking has been very important. This is the D School, so-called, at Stanford University. It's connected to an engineering program. And it's very much part of the curriculum at this school. Even the US military is very interested in design thinking. They are teaching this in a number of war colleges. This is a war college in Kansas, but they also use this as an approach at the US Naval War College in Northern California. 2 papers. Okay, so but what is intelligence? Let me try to be clear about what I mean by this. It's a book published, I guess 7 or 8 years ago, no, maybe not that long, 6 or 7 years ago, by a guy named Jeff Hawken. He's the inventor of the Palm Pilot, the software first, and then the machine itself. He's an interesting guy. He was an entrepreneur. He went back to school. He did a PhD in neurobiology. He was interested in the brain, the way the brain works. He did a dissertation on intelligence, and this is a piece of that dissertation, but he has an interesting idea about intelligence. Intelligence is not being smart. It's not the storage of a lot of stuff. For him, intelligence is a simple thing. It's the brain having stored a certain number or a certain quantity of patterns, and the brain projects those patterns into the world, and when those patterns don't accord with what the brain finds in the world, that difference gets re-registered as new patterns. So basically, intelligence is the production of knowledge by projection and reinscription of patterns. So projecting patterns, if the patterns are the same, then nothing new is added. If the pattern is different than what it finds in the world, that creates new information, and that new production of knowledge goes back and gets rewritten as new patterns. This is his basic argument. He says, intelligence is measured by the capacity to remember and predict patterns in the world, including language, mathematics, physical properties of objects, and social situations. Your brain receives patterns from the outside world, stores them as memories, and makes predictions by combining what it has seen before with what is happening now. So what's significantly different about this model is that, unlike with the ideals of modernism or with the ideologies of postmodernism, knowledge is being produced. It's not being sought as though it already exists in the world. It's literally being produced. Prediction is not just one of those things your brain does. It is the primary function of the neocortex and the foundation of intelligence. The cortex is an organ of prediction. If you want to understand what intelligence is, what creativity is, how your brain works, and how to build intelligent machines, we must understand the nature of predictions. The human cortex is particularly large and therefore has a massive memory capacity. It is constantly predicting what you will see, hear, and feel, mostly in ways you are unconscious of. These predictions are our thoughts, and when combined with sensory input, they are our perceptions. I call this view of the brain the memory prediction framework of intelligence. Now, I don't really care if he's right. As a neurobiologist, I couldn't tell you if he's right. It's an interesting idea. It's an interesting model of intelligence that accords with a lot of other things that I want to show and talk about. And for that reason, I think it's compelling. I mean, it is his thesis. It's been argued. There's a lot of debate about this, but it's an interesting model. It's a similar idea that Stephen Johnson has about pattern recognition and the projection of patterns and the restorage of those patterns as forms of knowledge. For me, again, just to reiterate, what's important about this is the production of knowledge or new information. There's a really terrific book. It's called On Bullshit. You may have read it before. It's a very thin little book. It's one of my favorites. In the book, it's a Princeton professor of moral philosophy wrote this book about 3 or 4 years ago. In the book, he says the world is becoming so full of bullshit that we don't know the difference between the truth and what's not true anymore. And he says there are these two kind of people. Yeah? They're liars and bullshitters. Now, liars are interesting because liars are the same as the people who tell the truth, because they know the truth, so they're lying about the truth. Bullshitters are interesting because they don't have any interest in the truth at all. Their interests are simply in an agenda. They have an agenda. So what they do is they produce bullshit to cover over their agenda. Now, liars may be bad, but at least they know the difference between what's true and what's not true. Bullshitters may know, but they try to cover it over. Now, it's an interesting distinction that he makes because he believes these people are problematic. Yeah? He likes these people better. I actually find these people much more interesting, except the problem is they're not interesting enough. I think there's yet another category of people who are even more important than these people. Now the reason I find this kind of interesting is that there's one of the most important sort of theorists of design thinking is a guy named Larry Liefert. He's a researcher at Stanford University in the D School. He's an engineer. And you can't read this, but what he basically says is, I was at the supermarket and I picked up this little book on bullshit and I found it incredibly useful because designers need to know something about this book. And what he says is, what we don't do as designers often enough is to suspend the possibility that something might not be possible. And so what we need to do is to, and he talks about a bull session, which is where people sit around and they'll say things that would normally they would be constrained by. So you sit around and you just like shoot the shit is what they say, right? That's what the bull session is about. So Larry Liefert says, this actually is just like brainstorming. This is really interesting. We should do more of this BSing. This is interesting. Now the problem, here's my problem with the BS, and this is why I want to get back and talk about design thinking and intelligence. BSing is a form of covering, they have no interest in true or false, but they have an agenda. There's an agenda. And the agenda of the BSer is to cover over the interest in the truth or the false and to get on with that agenda. So they'll say anything to advance their agenda. This is my problem with the BSer. So they're BSing you to get somewhere else. The intelligencer, which I think is a third character that we could talk about here, has no interest in truth or false, like the liar and the truth teller, has no agenda, like the BSer, but suspends belief and is interested in truths that might be possible in the same way that the BSer is, but not because they're covering over an agenda, but because they're producing knowledge that's useful. Okay, so this is the part that I want to read, if you don't mind. Anyway, it's a piece I wrote about their firm, but it's more generally about the engineer in design thinking, and the difference between the engineer and the architect in their approach to design thinking. So this will take a few minutes, but bear with me. Okay. Recently, as the limits of what could be built and what could not be built were pushed to new extremes by the insatiable market-driven appetite for more and ever more complex and formally exotic buildings, the architect and the structural engineer became a close, if not an inextricably linked pair. Cutting-edge architects in particular seemed incapable of building the shapes and forms that issued from their computers without a cutting-edge structural engineer. Everybody has an Arab person. Even at SCI-Arc, teams and studios would have an Arab person. I didn't fully understand that, but there would be a team of like 4 students, and they would have an Arab engineer working for them. And yet, however close the engineer and the architect, each has a professionally, legally, and culturally designated role to play in the making of buildings. The architect is the creator who makes the designs, and the engineer the analyst and tester who optimizes and makes those designs buildable. That at least is the conventional understanding of their relationship. There are, of course, many notable historical and contemporary exceptions to this convention. Engineers like Brunel, Eiffel, Nervi, who stand with one foot on either side of the line that separates the design from its optimization. But such examples of boundary crossing or straddling, as it were, affirm rather than contradict the line itself. A more fundamental and persistent transgression of the line commenced in London with the founding in 1946 of OVA-Arup partnership, a structural engineering practice now so identified with design innovation that Arup has become, for all practical purposes, an eponym for design engineering. Collaborators in the design of some of the world's most daring and compelling buildings, OVA-Arup himself and later Peter Rice, Ted Happold, and now Cecil Baumann have each made the line between the design and its engineering more difficult, if not impossible, to draw the line. Baumann, who's collaborated with many of the world's leading architects, has so blurred this line that he leaves architecture critics like Charles Jenks in a quandary about the role engineers do and should play in such collaborations. Writing in the preface to Baumann's most recent book, The Informal, Jenks makes the following somewhat discomfited admission. Quote, "In 1997, when I tried to list the 15 most important buildings and projects that were changing architecture, I found to my amazement that Baumann scored higher than any architect on the list. That is, if one is to credit the engineer with partial creation." It's this idea of creation. Is the engineer, what the engineer is doing, creative? Is it design? As if calculated to make Jenks and other like-minded critics squirm, Baumann, throughout The Informal, delights in disclosing the intimate details of his collaboration with architects. Entries that read more like personal diary scribbles than an engineer's calculation reveal a hand involved in practically all, including the very earliest stages of design. Baumann does this, however, not to assume the role of architect, but instead to show that he is on equal design footing with the architect and indeed with all his collaborators. Baumann's behind-the-curtain glimpse into the design process, and I'll show you a picture. You're design students, after all. Of the structural engineer shares with Peter Rice's wonderful book, posthumously published book, An Engineer Imagines, a professional concern to reveal the creative role engineers play in the design of buildings. Rice begins the role of the engineer, perhaps the most enlightening chapter in the book, with the following observation. This is what Rice says. "I am an engineer. Often people will call me architect engineer as a compliment. It is meant to signify a quality of engineer who is more imaginative and design-oriented than a normal engineer. If people find an engineer making original designs, which only an engineer can make, they feel the need to grant him or her a higher accolade, hence architect-engineer." Rice goes on to point out that the engineer's work is just as imaginative as that of the architect, the principal difference between them being that the architect works more subjectively to create, while the engineer works more objectively to invent. Rice believes that both the architect and the engineer are designers, though each has a different design process. Architects approach design problem from the standpoint of their own personal design signature. They are often hired, Rice notes, to solve a design problem precisely because the way they will respond and even the style of the response is known beforehand. After all, it is the solution, recognized before and after the commission in the architect's signature style, which the client seeks in searching for an architect. The engineer, on the other hand, and this is important, approaches design problems as if the solution were not known in advance and therefore needs to be produced. If successful, the architect designs a new solution, but one that he's already been chosen for, that is anticipated in the design problem he's given. While for the engineer, success depends entirely on designing an innovative and therefore unanticipated solution. So the engineer designs something that is unanticipated. Rice insists that this goes for all engineering, not just for the obvious innovations, such as the many he engineered in his own illustrious career at Arup. There are, he believes, engineering innovations occurring all the time. It's just that we don't pay close attention to them. If we were to take careful notice of the engineer's design process itself, Rice suggests, we would be better able to understand the originality of his inventions. Probably every solution put forward by an engineer has some unusual element, some feature that could be called innovative, but it is not recognized because it is buried in an otherwise conventional solution. And if we examine the nature of these otherwise innovative or inventive elements, we will find that it is just the result of the engineer, and this is his quote, it's a result of the engineer being intelligent or sensible about the way some detail has always been, and in so reassessing the problem from another point of view. The engineer sees a problem, he looks at the history, or she looks at the problem of the history of the problem and tries to understand those problems from another point of view. Rice here reveals in this short passage the key to understanding the engineer's design process. Rather than design alternative solutions to the problem, the engineer instead reassesses and reposes the problem from another point of view. The engineer is not interested in the solution, he's interested in the problem. Engineering problems, Rice says, are shaped by objective parameters, and so each problem has only one solution. That is why the problem must be approached with an intelligence that comes from knowing about the problem and the way it has always been, as well as knowing and understanding various solutions to an array of similar problems and the objective parameters that shape them. I'm not going to read much longer, don't worry. Rice says that in his own case, innovative solutions arise unexpectedly, often while working on another problem, as occurred with the structural solution for the floor of Lloyd's of London, which came to him when he was working in Turin on a project for Fiat. What is more, innovations come not because engineers go looking for innovative solutions, but they come as a result of the engineer's shaping and reshaping of the problem. Solutions are not always final solutions and are often more important in helping lead the engineer to more clearly define the problem than they are as designs in their own right. It is this sensible approach that in fact defines the engineer's disposition toward the problem. As each problem is shaped by objective parameters, so then are these parameters shaped by a particular point of view. And it is just these points of view that the engineer considers and reconsiders in shaping each proposed solution, until finally the right problem emerges. Invoking the title of Rice's book, we could say that the engineer imagines alternatives that reveal what the design solution might be, depending on which parameters are considered in the posing of the problem. Breaking with the what if, breaking with the what is in favor of the what if, the engineer uses the design to think through and solve problems, not the other way around. It doesn't use problems as a way to come to a design. It uses designs as a way to solve problems. Knowing which parameters, which what if to work with, and in what ways is enhanced and expanded with every new problem the engineer poses and solves, whether it results in an innovation or not. Even within the framework of a single design problem, each parametric change and subsequent question and solution increases the engineer's design knowledge or intelligence about a material, a structure, or a process. And this knowledge can become important in other or future problems when adjusting the parameters that shape those problems. The rewards of innovation extend then beyond the immediate problem at hand and become engines for creating new design knowledge or design intelligence that further enhances the engineer's ability to design innovative solutions. That's Peter Rice. I'm almost done reading, sorry. By focusing on the engineer's design process, Rice ultimately leaves us to draw the surprising conclusion that design drives innovation rather than the other way around. That is, if by design is meant not only the architect's creation, but also the engineer's invention. Design, as we see in examples ranging from Gary's Bilbao Guggenheim to the Apple iPod, has become an important feature in a dramatically, rapidly disappearing innovation-driven economy. But it is not only the design that is important. What is perhaps just as important is the value added by what design leaders like David Kelly of IDEO call design thinking, a form of design prototyping that follows a classic distinction made by business thinker Peter Drucker between problem solving, which answers without questioning the problem given, let's just say this, and therefore adds nothing new, and innovation, which interrogates and reforms the problem given, and it adds value by creating new knowledge and new products not anticipated in the problem. Problem solving shapes the known while innovation coaches into existence the unknown. Design thinking, then, is a thinking by doing in which plausible solutions are prototyped, interrogated, and redesigned. Prototypes, which IDEO calls the shorthand of innovation, are not, however, variations of a projected final design. Design thinking is the thinking by doing in which plausible solutions are prototyped, interrogated, and redesigned. Prototypes, which IDEO calls the shorthand of innovation, are not, however, variations of a projected final design. They are not guesses extrapolated from the designer's perfect idea about what the final design might be, but are instead what-ifs that the designer uses to drive the innovation process itself. The designer uses the prototype to think through as many factors as necessary, material cost, fabrication, etc., and adjust the design accordingly. Not only are the assumptions of the problem given transformed, opening the way for innovations, but also with each new prototype, design intelligence is generated that can be shared and discussed among teams of designers whose additional input further enhances the innovation process. Okay. I'm going to move on past that. So I guess the larger point there is that I really want to get at is with Rice, the argument is that the engineer imagines by using the design as a way to rewrite problems and to discover in that process or to produce in that process innovations that would not have occurred had the problem simply been solved in the form that it was given. Let me give a quick example. If you're an architect and you come to me, or if you're my client and I'm an architect and you come to me and you give me a problem, I want a blue house with a green driveway and yellow windows. If I give you that, I'm not adding value. I'm simply solving the problem that you gave me. If you come to me with that and I say, look, I think the yellow windows are a problem. I think you need green windows and a purple driveway. Or you don't need a driveway, or you don't need a house at all. I'm reshaping the problem and I'm adding value, perhaps, to the problem that you've given me. And if I do that, if I add something to what you bring me, then I'm worth something more than the crap that architects get paid for solving people's problems. So the argument is basically that architects can learn something from engineers about design innovation by reforming and reshaping problems. Okay, there's some practical examples of this. So the fabricator and the architect. The architect, Marcello. The architect always has a scarf, yeah? You know that. In this case, it's a black one, not a red one. And the fabricator, who is already thinking with his hands, yeah? And then they are in a conversation with yet a third person. Yeah? Now, Marcello has come with a problem to the fabricator, which is, I have this great idea for this beautiful design on Santa Monica Boulevard. Can you make it for me? Yeah, because I don't know how to make it. I can design it. I can make it really beautiful. Yeah, but I don't know how to make it. And so this is the conversation they're having. Marcello says, look, this is really going to be gorgeous. We can make it out of this. We can make it out of that. Look at this thing. We can put it on our CNC machines and spend hundreds, and we can do all these things. And Ruben, the fabricator, says, yeah, okay, that's fine, but I don't think that material is going to work. I don't think those joints are going to work. I don't think what we need to do is you need to give us this, and we need to test this. You know? So Marcello gives the design to Ruben. The material fabricator tests the proposal. They go back and they go forth, and as they're doing this, Ruben's company begins to learn all kinds of things about the way this material works. They begin to learn things about how it fails, how it succeeds, what it can do, what it can't do, what Marcello's design can do, what it can't do. Ruben stands back and is learning the whole time. Because what Ruben's doing, what Ruben's firm is doing, is they're prototyping. They're creating what-ifs. If we did this and this and this, it would look like that. If it fails, they know that. What they're doing is they're building a catalog of knowledge about Marcello's project that Marcello has no idea about. Because at the end of the day, Marcello is really interested in the beautiful building that we can photograph and put in a magazine and put on a cover. And Ruben is interested in figuring out how to make it, but also Ruben is interested in creating a catalog of testing and building a body of design knowledge that he can take to the next project. Ruben can now take the knowledge he's generated through designing Marcello's beautiful design, and he can and the next client will actually pay him for that. Marcello gets a beautiful building, and he gets a beautiful cover for a monograph, but that's all he gets. And eventually what happens is that Ruben's company then begins to hire Marcello's students to be Marcello. Yeah? Because in this model, the person we don't need, yeah, and the story of Ruben and Marcello is Marcello. You. We don't need you in this example, yeah, because you're not interested in the production of the design knowledge that can be repurposed and taken into new projects. You're interested in this, yeah? And that's why Ruben's company will hire you and your students.